Good day, everybody. How are you all doing? This is Dr. Nandi again, working on another problem in stats. And the problem states if a set of measurements is normally distributed, what percentage of measurements differ from the mean by part A, more than half the standard deviation, and part B, less than 3/4 of the standard deviation. So we will solve this problem. First, we will draw a standard normal curve. Okay, so the center where the peak is the highest is the mean. Okay, so this is a z-scale on the horizontal axis. For a standard normal curve, this is the standard normal curve. At the center, z is equal to 0. This is 0. And we are on both sides of the mean by half standard deviation. So the z-score over here is 0.5 and the z-score on the left of the mean is minus 0.5, roughly over here. So let's work on the right side of the distribution, right side of the mean, that is right side of the vertical line at the center. So we want to find the area which is on the right of 0.5 by more than half. So we want to find out basically the area of this. Okay. So we are more than half a standard deviation on the right of the mean. Okay. So area, to find the area to the right of z equal to 0.5, we will use TI 84 calculator. Now the question may be, why is the z-score 0.5? Now remember, z-score indicates how many standard deviations you are away from the mean. If you are half standard deviation away from the mean, the z-score, if you're positive 0.5, then the z-score for that point on the horizontal axis, as I have shown, is 0.5, because z-score indicates how many standard deviation you are away from the mean. If you are away from the mean by 0.5, the z-score is 0.5. Okay, so we are going to use TI calculator, 84 specifically. So you press the second button, then we press the verse button, which is in the third row of the calculator. Then we scroll down to number 2, which is normal CDF. This function helps us to find the area under a normal curve. Okay, so let's do that. Second button, then the verse button in the third row of keys. Then we scroll down to number 2, which is normal CDF. Notice in this case, the lower boundary is not minus 1E99 as shown in the calculator. Actually, the calculations go from left to the right. So here the lower is 0.5. And then what is the upper? Upper is a very large number on the right, which is 1E99. So first we type 1, then we type the second button again, and then the comma button, which is on top of 7 button. This is the comma button, and that will give us the small capital E, and then we will type 99. I want to mention what is 1E99. It's 1 followed by 99 zeros. That means a very large number on the right hand side, or in this case is infinity. So we start on the lower boundary by 0.5. In the upper boundary we type 1. Then second button and comma button, which is on top of 7. This gives me the capital E, 99. Now we are dealing with a standard normal curve. So mu is 0, sigma is 1. Leave it alone. That's what it is in the calculator. And then we will go on the paste. If you have watched my previous videos, as I have mentioned, when you are on paste, hit enter twice. Enter button twice on paste. And the answer is, so, sorry, area under the standard normal curve normal curve to the right of z equal to 0.5 is, how many places we should go? 4 places is good, is 0.3085. Now remember, the normal curve is symmetric. That means what happens on the right half of the curve to the right of the center, same characteristics on the left half of the curve. That means this area is also, area is 0.3085. Same as this area, which is 0.3085. Why do we need the area to the left of minus? So this is, remember, z is minus 0.5. So we need the area to the left of z is minus 0.5 as well as the area to the right of z equal to 0.5, because these two added together will answer part A, more than half the standard deviation. So it can be half the standard deviation on the right and more than half the standard deviation on the left. So area, let me clear that, area under the standard normal curve to the left of z equal to minus 0.5 is by symmetry (0.3085). So the question was, what percentage? So the total percentage of numbers, what percentage, total percentage of points which will differ by more than 0.5 standard deviation from the mean, is 0.3085 on the right plus 0.3085 on the left, which is 0.617. Sorry, I wrote it wrong, so I got to correct it. Let me erase this way, is equal to 0.6170, or 61.7% will differ from the mean. By more than 0.5 standard deviation. So let me quickly go over what it then says. What percentage of measurement differ from the mean by more than half? So we find the area to the right of z-score of 0.5, okay, using the calculator, and it is 0.3085. There's an equivalent area on the left of z equal to minus 0.5 on the left of the mean. which area we should be also 0.3085 because of symmetry. So total percentage of numbers which will differ from the mean by more than half standard deviation is 61.7%. Okay. Now the part B is less than 3/4 standard deviation or 0.75 standard deviation. So in this case, you have to remember when we are talking in terms of how many standard deviation, 0.75, the z-score on the right of the mean will be positive 0.75 and z-score on the left of the mean will be minus 0.75. Remember, z-score is a measure of how many standard deviations you are away from the mean. So let's draw the normal curve again. Okay. So you are away from the mean by 0.75. So z in this case will be 0.75 because in the center z is 0 and on the left of the mean z is minus 0.75. And we want to find out the total area in between them. Of course, we will only find we can actually go use TI-84 to find the total area under the standard normal curve. So this is the standard normal curve, which means at the center z is 0, mean is 0. It's normal curve whose mean is mu equal to 0 and sigma is equal to 1. Okay, so again you go to TI-84, second button, then the verse button on the third row, then select number 2, which is normal CDF. In this case, the lower. Now we have to be careful. Second, verse 2. The lower is minus. Do not press the minus on top of the plus. This minus sign on the left of enter at the bottom right. So first press that minus on the left of enter at the bottom right corner. So minus 0.75, but because that's your left boundary or lower boundary. And the upper boundary is just 0.75. So type in 0.75 for the upper boundary. Again, the mean is 0, standard deviation is 1 because it's a standard normal curve. We paste. Again, to remind you, for paste we have to hit enter twice. Enter twice. Enter button twice. Okay. So when we do that, the total area, so percentage of measurements, which are less than 0.75 standard deviation from the mean is equal to total area 0.5467, or the answer can be written as in percentage 54.6% of the measurements less than 0.75 standard deviation from the mean. And just to recapitulate what we did, we understood that less than 0.75 standard deviation from the mean. Okay, that means on the right the z-score on a standard normal curve on the horizontal axis on the right side score z is 0.75, on the left side z is equal to minus 0.75. We draw two vertical lines to indicate the lower boundary and the upper boundary. Then we went to TI-84 and found the area under the standard normal curve between z equal to minus 0.75 and z equal to 0.75, which came out as 0.5467. What does it mean? The 54.67% of the measurements vary from the mean by less than 0.75. Notice it can be on both sides of the mean. So I will stop here today. Please write me a comment. I really appreciate that. And please give me a thumbs up if you really like this video. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget to watch me tomorrow when I'll be back with another interesting situation. Thanks for watching. Take care. Have a nice day.